Hello and welcome back to the channel. In this video lecture we shall be continuing with the problem which we solved in the previous video, that is substring with concatenation. We solved this problem using a brute force approach. In this video lecture we shall be solving this problem in a more optimal way. So if you haven't watched that video, make sure to watch it, then you will understand the solution which we are discussing here in a better way. So the problem was, we're given a string S and an array of strings words. All the strings of the words are of same length, and a concatenated substring in S is basically a substring that contains all the strings of any permutation of words concatenated. So we are given this words array. We find a substring using all the words of this array, and then that substring that we generate is a valid substring, and we have to find all such valid substrings in the parent string S. We want to return the starting indices of such substrings if they are present in the parent string S. Okay, so that is called a concatenated substring. We can return the answer in any order. So we can return the starting indices from left to right or from right to left. Fine, let's see the constraints of the problem. The length of the parent string may go up to 10,000, while the length of the word may go up to 30, and the number of words in the given array may go up to 5,000, and the string and words contains lowercase English letters. Let's better understand the problem statement using an example. So let's take the recap of the previous solution that we discussed, namely the solution in which we checked all the indices. So in this solution, what we have to do is we start from each index of the parent string, and we try to check for each index if the target substring is present or not. For instance, in this case, we have two target substrings that we can find or we want to find in this parent string. So these are the substrings which we want to find in our parent string because they are formed from some permutation of the words given in this array. Then we start from the first character, that is B, and we check if the substring of length 6 is present here or not, and the answer is yes, it is present here. So we push 0 in our answer array, because this is one of the indices where our valid substring or concatenated substring starts. Then we check for the next index, that is A, where we do not find any of these substrings. Then we go to next index and so on. Here in this case the answer would be 0 and 9 because we find valid substrings at these indices. So we can return the answer in this order or in this order. Both of the solutions are valid. So this was the brute force approach to solve this problem. So we checked all of the indices and finally we obtained our answer in our array. But there are problems with this solution. Let's see what are those problems. Let's understand the problems with the naive approach. So let's take this example. This is the parent string and this is the words array. So only two substrings would be valid if you want to find. So the first one would be this and the second one would be this. We want to find only two substrings which are present in this parent string. Then let's see the problems that we face here. So this is the hash map. Okay, so if you're not getting why we are building this hash map, then make sure to watch the previous solution where I discussed the naive approach to solve this problem. So I have this hash map where I have my entries of these words. Then I start traversing my parent string. I find a valid substring at the first index, that is this substring BARFOO. Then I find my second valid substring or second concatenated substring at third index here, that is this string. Then I find my third valid substring at sixth index, that is here, and the string is this one. Here I can see that I'm traversing this part, that is FOO here, and I'm traversing it here again. So this is the part which I am traversing twice. Then in this case I'm traversing this part bar twice while I find my second substring here, and then I find my third substring here. I am traversing this word twice here. You can see that. So that is the problem with this naive approach. Why it is a problem? Let's see. Maybe it is easy to overlook for this particular example, but let's take an example like this. This is a string S. It contains 10,000 characters and all the characters are same, that is A. And the words array contain the strings which contain only character A, and the length of the word may go up to 5,000. Let's apply the naive approach for this particular input test case. We can see that I want to find the valid substring of length 5,000. 5,000 multiplied by the length of each word, that is 1, which is giving me 5,000. So I take first substring of length 5,000, and in that substring I will find all the words are present in this words array. So for the first character where I'm starting, I'm trying to search a substring of length 5,000, and then I'm iterating over my words array, and I can see that I will be traversing 5,000 times for the first index. Then I move to my second index, that is A, and again I will find 5,000 valid words in this words array, and hence I would be iterating 5,000 times again. So how many times I would be iterating 5,000 times? Since I have all the characters same, that is A, and the words in this array are also A, then I have to start at every single index. Hence I will iterate 5,000 times for all of my roughly 10,000 indices. So this is going to give me a huge number, greater than a million. And hence to find valid substrings, I have to traverse over this string over 1,000,000 times, which is a redundant computation because I am traversing 5,000 times, then I'm starting with the second index and I'm again traversing 5,000 times. Hence this is a suboptimal solution. We have to improve upon this. For these kind of test cases, that solution will fail, although the constraints do lie within the constraints of the problem, but still it will fail. So let's discuss the better approach to solve this problem. So the better approach to solve this problem is sliding window. We would be solving this problem using sliding window. So we know what is sliding window. In sliding window, we basically take two pointers. We put one pointer at one character and another pointer at some other character, and this part which is covered by these two pointers is what we call window. So this is a window. Fine. Then all we have to do is to find the strategy to move this window across the given string, which fits in with our algorithm. Let's see how we can decide the strategy of these pointers or window. So let's take the first word. So we have this string given. So this is string S and this is case number 1. We take two pointers. Okay. So this is case number. So this is the string that we are given, and these are the words that we would be given in the words array, and we construct a hash map over these words. So this is a hash map which we build over the given words. Fine. And we want to solve this problem using sliding window approach. How do we solve this problem? We take two pointers. One pointer we call as left pointer. So this is a left pointer. Another pointer we call as right pointer. From the given words, we can see that we have 3 words and the length of each word is also 3. So the valid substring that we want to search in our parent string is of length 9. Fine, because we want to use all of these words to construct our concatenated substring. Hence, we take two pointers. First pointer we initialize with the first index, that is index 0, and the second pointer we initialize with 3 because 3 is the length of the word we are given. That means we are at least checking for a word. So we are starting with one word. Okay, so here we put our right pointer. Then I see that then I want to find the strategy to move these pointers. Fine. So we move our right pointer ahead and we check the next word of length 3. We see that THE is not present in the given hash map. Therefore, here we conclude, here this is the case where we encounter an unknown word. So here we have encountered an unknown word, the. Therefore, no matter where we move, how far we move our right pointer towards right direction, this substring of length 9 will always be invalid because it contains a word, the, which is not present in the hash map or the words array. So the wise decision here would be to start the left pointer right from this position. So left, I move here. Now my left pointer is pointing to this position. We skip over the unknown word. Why? Because I'm sure that I'm not going to find any valid substring which starts from any character in this part. Therefore, I initialize the left pointer here and again I move my right pointer towards right direction and so on. So this is the first case when we encounter the unknown word. That's how we move our pointers. So this is the left pointer here and the right pointer will again start from, so this is right pointer, and then I will check the next word. Let's see another case. The another case is we find an access word. So this is the case number 2 where we have an access word in the window. So this is our current window. We have found FOOBAR and in the third word we have a repeating scenario. We have a word which is repeating. So here we have bar, then we have bar again. How do we move our pointers in this case? In this case, we know that we would not be finding any valid starting character in this part. That is for sure. Because this part is repeating, it is unwise to start from this position or some other position which exists here. The obvious decision would be to start from this character. Fine? Because this word is repeating and we do not want a repeating word in our concatenated substring. Therefore, how do we move our pointers? We initialize the left pointer at the starting of the repeating word. So I initialize the left pointer here. Now my left pointer is, and the right pointer points to this position. And I want to find the next word here. This is how I'm deciding the strategy of my pointers to search for the target substring. Fine. These are the two cases which we're gonna encounter while moving our window. Fine. So the strategy is simple. We start with 2 pointers. We make jumps of length 3 or word length that we are given in the words array. Whenever we encounter an unknown word, so the jumps are made by the right pointer, and whenever we encounter an unknown word like we encountered here, what we're gonna do is we would be starting, in this case we would be reinitializing our left pointer to the character right next to the ending of the unknown word. This is the case number 1. While in the case number 2, when we find a repeating word, in that case we will be initializing our left pointer to the starting of the repeating word as we did here. So this is a strategy with which we would be solving this problem. Fine. So let's discuss the implementation of the approach that I explained here. Most of the implementation stays the same, which I explained in the previous case. I again repeat, if you didn't watch that video, it would be a little difficult for you to understand how I am moving here. So here again I am taking the hash map, which is a global hash map and represents the length of the parent string s. Word length is the length of each word in the given words array, while the substring size is the size of the string, concatenated string, which we want to search, while k is the length of the words array. This is sliding window function which we would be calling for the indices, and left is the starting index. Initially we call it at index number 0, then s is the parent string, while answer represents the answer array where we would be pushing the valid indices. Here we take a local hash map words found, which is used to check for the presence of the words in the current window, and a words used variable. This variable would be used to count the number of words used in the current window so that I can match it with the number of words which we want to use to construct the concatenated substring. While this is a Boolean variable access word which is initialized to false, it represents the case number 2 here, which I explained in this case, and it is true when we encounter an access word, and it is false when we do not encounter any access. Then I iterate over the string starting from the index I passed in this function, that is left, and I make jumps of word length. Fine. So here in this case, like the word length is 3, so I make jumps of size 3 and I move it till n minus word length, because let's say this is n and the last valid substring would end with the word here, would end with the word starting at index n minus word length. That's why I'm iterating for n minus word length times. Then for each starting index, I construct a substring of length word length, and I check if this substring is present in the hash map or not. So I have already constructed my word count hash map beforehand using the words array we are given. So I insert all my entries in the words array into this hash map. Then I check if the particular word is a valid word or not. That means if it is present in the words array or not. So here it is not present. If it is not present, then that means I am encountering this case where I have an unknown word. That means the word I constructed here, which is present in this substring, is not present in the words array. Therefore, I clear my words found hash map. That means I want to start with a fresh substring. Then I also reinitialize my words used variable to 0 and the access words variable to false, because I'm starting with the new substring. And the left pointer would be moved to word length ahead of the right pointer, which I explained here. Since I encountered the here, then the left would be moved 3 characters ahead of right pointer, that is here. That's what I'm doing in this case. Then this is the case number 1. So this is the case number 1 which I discussed in the first slide. Then we have case number 2. In that case, we encountered a repeating word, and if it is the case, then what do we have to do? We move our left pointer until I subtract my repeating word. So what I did here, I found a repeating word at this position, then I moved my left pointer towards right direction until I do not have any repeating word. So the left pointer would be here, because up until this point, because before this point I always had bar as a repeating word. Therefore I had to move my left pointer up until this position. So that is the case which I am handling here. So this is the leftmost word. I take each word starting from the left pointer of the length word length, and I move my pointer left by word length, and I decrement the current word which I have in this substring. So I'm extracting this word out of my window, out of my current window. Fine. Until I make sure that I do not have any repeating word in my window. So that's what I'm checking here. If after extracting the word, after removing the word, leftmost word from the given window, if the count of this word in our current window is more than the count which is present in our global hash map, that means this was an access word and we removed an access word from our window. And since we have removed the access word from the window, we turn our boolean variable to false. That means we do not have any other access word till this point. Otherwise, this was not an access word. Therefore, I decrement the words used by 1. That means we have removed one word from our current window. And that means the word that we removed was a valid word. So this basically stores the number of valid words. Valid words are the words which are present in the words array. Fine. Then, so this is the case number 2 which we are handling. In case we are encountering with a repeating word, then we put our current word into our words found hash map, and we check if the current word sub appears less than the number of times it appears in the global hash map. If this is the case, then this can be used as a valid word to construct our target substring. Hence we increment the words used variable by 1. Otherwise this is an access word and we turn this variable to true, because the words found hash map contains the presence of this word more than it is required in the final substring. Therefore we turn the access word to be true. Finally, we check if the number of words that we have used to construct our current window is equal to the number of words that we have in our words array, and we do not have any access words. So we have to make sure these two conditions. If this is the case, then that means the left index is the starting index of the valid concatenated substring, and hence we push this index into our answer array. Fine. So that's how this code is working. This is the implementation for the logic that we have. All we have to do is to start with 2 pointers. We make jumps of length words, that is the length of the word, and we would encounter 2 cases, case 1 and case 2, that we handled here. The case number 1 is the case where we encounter with an unknown word, and the case number 2 is we encounter with an unknown word, and case number 2 is the case when we have a repeating word in the given window. So I hope you understood how we handled these 2 cases, and finally we would have the answer array constructed, which would give me the indices, the starting indices of the valid substring. Now let's discuss the time and space complexity for the given solution. Let's say n, a and b represents the length of the parent string words array and of each word. B is the length of each word. So in this sliding window function, this loop runs for n by b times. N is the length of the string, b is the length of word, because we are making jumps of length b here, which is word length. Then for each iteration, we are creating a substring of length b, that is here, this substring, which takes big of b time complexity. So in the nested while loop, which we are using in this case, that is case number 2, we are constructing another string here, and this loop will run b times, like overall b times, and this is taking b time complexity because the substring that we are constructing is of length b. Fine. So this gives me b plus b, that is 2b time complexity, and since we are iterating n by b times, this would give me n by b multiplied by 2b, which is big of n, and hence this loop here is taking linear time complexity, and n is the length of the string s. How many times the sliding window function is called? This sliding window function will be called b times. Therefore, the overall time complexity becomes n into b, while this a factor comes from iterating over the words and constructing the word count dictionary, that is the global hash map. So finally the time complexity becomes a plus n into b, while the space complexity is a plus b, where a represents the length of the words and b represents the length of the string. Why? Because we are using a hash map which stores at most a entries, while we are using a substring, we are constructing a substring sub here, which is used to check for the current word. That is taking a space complexity of big of b. Hence, the overall space complexity becomes big of a plus b. Fine. So that's the time and space complexity. Let's move into the implementation part. Okay, so this is the substring with concatenation function. So here we declare a global hash map. Then we declare the size of the parent string, and then we have a variable representing the length of each word, that is word length. Then we have a variable substring size, which represents the size of the substring, concatenated substring, which I want to search. Then I have the size of the words array, that is. Then I construct my function sliding window, which takes in the index, left index of the window or the starting index of the window, the parent string and the answer. In this function, I declare a temporary hash map to store the entries which are present in the global hash map. Then I declare a variable which will be used to count the number of words which are present in the current window. Then I declare my boolean variable to check if there is an access word or not in the current. Then I will iterate over the given string starting from the left index with a jump of word length, and I construct a substring of size word length. So for each substring or for each word added, what I have to do is I have to handle two cases. The first case is that if I encounter a word which is unknown, in that case I clear my present dictionary. That means I have to start from the next window. I have to erase all the words which are present in the current window, and that's why I am reinitializing the words found variable to 0 and I am turning the access word to false while moving my left pointer starting from the next character of the ending of the current window. Then I would have another case to handle, which contains, in that case, I will move my pointer left till I remove my access words from the window. And finally I check if the current word which I removed was an access word or not. Finally, we keep track of how many times this word exists in the window, that is the word sub that we are considering here. And I check if this word, which is sub in the current window, appears at most number of times it present in the word count hash map. If this is the case, then this would be a valid word and we can include it. Hence I increment my words found variable by 1. Otherwise I already have too many instances of this word and hence it is an excessive word. So I turn my access word variable to true. Finally, I check if the words found, the number of words which are present in the current window, are equal to the number of words which I require and there is no access word. In that case, this is the target index or one of the target indices. So I push it into my answer array. Fine. So this is how the function is working. Then I would create another function, that is find substring function. This function basically calls the above sliding window function for the given string s and the words array. I calculate the length of the string, the length of the array, length of each word, and the size of the substring which I require. So I am initializing all the variables which I declared globally. Then I prepare my hash map, the global hash map, and finally I call my sliding window function word length time, and this will construct me my answer. So I will return my answer right from here. So this is the implementation in C++. Let's see the implementation in other languages. So this is the implementation in Java and this is the implementation in Python language. So that's all for this video. If you like the video, then do like it and make sure to spread the word and subscribe to my YouTube channel. I will see you in the next video. Till then, bye bye, take care.